Hello math learners! We have already discussed two methods in solving system of linear equations, the graphing method and the substitution method. Today, in this video, I will teach you the third method of how to solve system of linear equations, and that is by the use of elimination method. So, before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency based lesson for quarter 1 week 8 of the grade 8 mathematics, which is all about solving system of linear equations using the elimination method. The question is, how do we apply the elimination method? Technically, what you will do is you just add the two equations, but before adding, make sure that one of the variables will be eliminated. Also note in this method the following three scenarios. If you will have a value of your x and y, then your system of linear equation is consistent and independent, meaning you have one solution. But if the variable will be eliminated and the given statement is true, then that is many solutions and the nature of your system is consistent and dependent. Otherwise, if it will become a false statement, then you will have no solution and the nature of your system is inconsistent. Okay, let us start the first example. We have here 3x minus 5y is equal to 13. That is your first equation. And this is compared with the 4x plus 5y is equal to negative 6. Now, how do we apply the elimination method? Okay, let's first write the equations. Okay, math learners, as you can see here, we have written our first system of linear equations. Now, what you will do using the elimination method is you just add the two equations. But be sure that when you add the two equations, one variable will be eliminated. Okay, now let us try first our x variables. 3x plus 4x, will that eliminate our value of x? Oh, it doesn't. Okay, now let's try here. Negative 5y plus positive 5y. Will that eliminate your y variable? Okay, it is. So therefore, we can apply directly our method. We just add our equations. So 3x plus 4x, that will give us 7x. By adding the y variables, negative 5y plus 5y, that will eliminate with each other. Now we can continue to our constant terms. 13 plus negative 6, that is positive 7. Okay, now by doing so, we will try to solve for our remaining variable, that is 7x is equal to 7. So we will divide both sides by 7. That will be cancelled. X will now be 7 divided by 7, that is 1. So now, you have a value for your x. Now, for you to have a value for your y, what you can do here is you just substitute this value of x to either one of your equations. So let us try substituting it to our first equation. We have 3x minus 5y is equal to 13. Then our x is equal to 1, so that will become 3 times 1 minus 5y is equal to 13. 3 times 1, that is 3, minus 5y is equal to 13. Now, since 3 minus 5y cannot be added together or cannot be simplified together, we will transpose our constant term to the other side, giving us negative 5y is equal to 13 minus 3, and that will give us negative 5y is equal to positive 10. By dividing both sides by negative 5, we will have y is equal to negative 2, because 10 divided by negative 5, that will give us negative 2. So, the value of our x is 1 and the value of our y is negative 2. Therefore, these two equations will intersect at 1, negative 2. Therefore, it has one solution. And if it has one solution, then the nature of its system is consistent and independent. Easy, right? Now, let us go to our second example. Okay, math learners, we are already in our second example. We have 2x plus y is equal to 7, and the second equation is 5x minus y is equal to 14. I have written it already here. Now, how do we solve this? First is you try to add the two equations. Now, make sure that when adding, one variable will be eliminated. 2x plus 5x, that will give us 7x, okay? Y plus negative y, that will become 0y, or that will eliminate our y. Therefore, we can now apply our elimination method. So by adding them, this will become 7x. By adding the y variables, this will become 0. Now we can just add our constant terms. 7 plus 14, that is 21. So we divide both sides by 7. In order for us to solve for the value of x, so 21 divided by 7, that is positive 3. Now, if you have the value of one variable, then you can substitute it to either of your equations. Now, earlier in our first example, we used the first equation. Now, let us try to use our second equation in substituting our value of x. So, we have 5x minus y is equal to 14. Then, our x is equal to 3. So, that will become 5 times 3 minus y is equal to 14. So, 5 times 3, that is 15, minus y is equal to 14. Now, I cannot add 15 and y, or subtract 15 and y. So, I will transpose my constant term to the other side, giving me negative y is equal to 14 minus 15. Okay, because 15 is positive here. When transposed, it will become its opposite value, minus 15. Now, by subtracting 14 to 15, that will give me negative 1. Now, if I will divide both sides of the equation by negative 1, my negative y will become positive y, and my negative 1 divided by negative 1, that will become positive 1. Therefore, the value of my x and y are 3 and 1 respectively. Therefore, this equation will still intersect at this point, and this has one solution, meaning the nature of its system is consistent and independent. Very easy, right? Now, let's go to the third example. Okay, math learners, in our third example, we have 2x plus 3y is equal to 7, and the second equation is x minus 2y is equal to 7. Now, I have written it here, and now we will try to apply our elimination method. 2x plus x, that will give us 3x. Okay. 3y plus negative 2y, that will give us positive y. Okay. Two of our variables are available and not eliminated. So, what can we do here? Okay. If this is the case, my dear math learners, what you will do is you will transform one equation to its equivalent such that that equation will help. When added to the first equation or the second equation, it will make one variable eliminated. Okay, how do we do that? As we can see here, 2x, this is x, right? Okay. So, what I can do is I will transform this second equation such that it will be eliminated to 2x. Now, positive 2x. What can eliminate positive 2x? Of course, that is negative 2x. We have here x. What can you do to this equation in order for its x to have a negative 2x as a result? Okay, so basically, you will multiply this equation by negative 2. Because if you multiply negative 2, this will become negative 2x. Okay? So, by applying, let's just write first our first equation, okay? And by applying our distributive property, negative 2 times x, this will become negative 2x. Negative 2 times negative 2y, that will become positive 4y. Negative 2 times positive 7, that will be negative 14. Okay. So now, as we can see here, these two terms can now be eliminated. Okay? So, we can now apply our elimination method. Adding them will give us 0. 3 plus 4, that is 7y. And adding this will give us negative 7. And then we divide both sides by 7. And our y is equal to negative 1. So now we have the value of our y. Now let us solve for the value of x. How do we do that? Let's just use our first equation. So we have 2x plus 3y is equal to 7. Now we have y as equal to negative 1. Okay? So that will become 2x minus 3 is equal to 7. That will give us 7 plus 3 because I transposed the minus 3 here to the other side, giving me positive 3. That will result as 10. Here, that is 2x. I will divide both sides by 2 for me to have a value of x. This will be divided by 2 and the answer is 5. Therefore, the value of my x is 5, the value of my y is negative y, and the equation will be in positive 5, negative 1. So still, this is a system with one solution. Easy, right? Now, let us go to our final example. Okay, math learners, we are down to our final example. We have x minus 4/5 y is equal to 2. And the other equation is 5/4 x minus y is equal to 3. Of course, by adding these two equations, we will never have an eliminated variable because this one are not opposites and this variable doesn't have opposite numbers or coefficients with each other. So how do we do this? I'm sure you are having a hard time if you just see fractions, right? Okay, so what I can do here is to transform these given equations into equations that have no denominators. How do I do that? I'll just multiply the whole equation by its denominator or its LCD. Now, for the first equation, we have 5 as its LCD. So, I will multiply the whole equation by 5. And for the second equation, I will multiply the whole equation by 4. Okay. By doing so, my first equation will become 5x minus 4y is equal to 10. How did that happen? 5 times x, that is 5x. 5 times 4, that is 20. 20 divided by 5, that is 4. Since this is minus, we just copy the minus. 2 times 5, that is 10. Easy, right? Okay, so that is equation 1. Now, let's try equation 2. 4 times 5, that is 20, divided by 4, that is 5x. 4 times negative y, that is negative 4y. And negative 3 times 4, that is negative 12. Okay, now, by just looking at this, we can now try our elimination method. If we add this, this will become 10x. If we add this, this will become negative 8x. So, question, how do we eliminate one variable? Okay, so we just multiply one equation with a negative 1 as its number in order for the equation to have opposite signs. Okay, I will try the second equation. I will multiply it by negative 1. So, I will just write the first equation, 5x minus 4y is equal to 10. Now, my second equation will become negative 5x positive 4y, and this will become positive 12. Now, if I add this, this will become 0. If I add this, this will become 0. So, that is 0 is equal to 10 plus 12, that is 22. 0 is equal to 22. Is that true or false? Of course, that is false. And if it is false, remember that if it is false, it has no solution. Therefore, your system has no solution, meaning they are parallel with each other, and the nature of your system is inconsistent. So that summarizes our discussion on solving system of linear equations by the use of the elimination method. Now, if you do have any question about our topic, just write your inquiries in our comment section below. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time in our discussion for today. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much to your support. And please, if you do like this video, kindly click that like button as well as share this to your friends, classmates, and other schoolmates. Take care, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.